Welcome to Study Loop.
Let's say we want to prove this identity that the limit of x to infinity of ln x over x to the p power equals 0 for any value of p greater than 0. Now, we can prove this by using L'Hopital's rule. And L'Hopital's rule basically says that when you're taking any limit to infinity of a fraction, so ln x over x to the p is a fraction, it's the same thing as the limit of the derivatives of the top and bottom of the fraction. So that means we can rewrite our limit, and instead of writing ln x, we can write the derivative of ln x, which is 1 over x. And then we can also write the derivative of x to the p. Now remember, p can be any number that's greater than 0. And we can use the power rule here. X to the p means we multiply by p, and then we decrease our exponent by 1 to get p minus 1 as our new exponent. Now, let's simplify. If we have 1 over x on the top, that's the same thing as having a 1 on the top and an x on the bottom. And then we just have our same denominator, px to the p minus 1. Okay, now, it can help here to put our x's right next to each other, because remember that when we have two bases that are the same, we can add the exponents. So we basically have 1 over p, and then we have 1 over x to the first, right? Because like any variable can be written as to the first, x to the p minus 1. So we're actually going to bring this 1 over p on the outside here, because our limit is dependent on x. So our p really doesn't matter here, right? So because we have a 1 over p, we can factor that out of the limit. And if we add our exponents here, we have 1. Actually, no, I'll like right over here. We have 1 plus p minus 1. And 1 minus 1 is 0. So these ones cancel each other out. So we're really just left with x to the p. So we have 1 over x to the p, right? And we know this limit is going to go to 0 because we have a denominator that keeps on getting larger and a numerator that is a constant. So this limit is just 1 over p times 0, which is just 0. So we've used L'Hopital's rule to prove that this limit goes to 0 for like values that are of p that are greater than 0.